Okay, welcome back. We're on page 169 talking about the difference between a command line interface and a graphical user interface. And yes, command line interface is still alive and well. And talk about that example when you're installing Windows Server and it asks you a question during the install. The idea is, let's say I'm putting together a web server, and that's the only thing the server is going to do. All it's going to do is serve web pages to people. That's it. Well, I don't need notepad and calculator and solitaire. I don't need a whole bunch of stuff because the only thing it's going to do is serve web pages. So I can strip down my operating system so it's tiny, tiny, tiny. And when you do that, you end up with a command line interface. And the first time I did that, I stood there and went, oh my goodness, I don't know how to do anything. I don't know how to change the IP address. I don't know how to change the machine name. I don't know how to make it join a domain. I had never done that from the command line ever in my entire life. And I spent the first 5 minutes going to Google saying, how do you add a machine to a domain? Oh, okay. It was rough, but could be done. All right, let's continue. The next thing we can talk about is, there's voice recognition. There's lots of other different kind of ways you can do computer interfaces, but come on, that's not normal. The next thing to talk about is hardware abstraction. They say hardware independence. The term I use is hardware abstraction. And here's how this works. Let's say, for example, I've got a computer a program that I'm writing, and it saves a file to a hard drive. Okay? You want it so that if the guy replaced the hard drive with another hard drive, or instead of storing it to a hard drive, he wants to store it to a network location. Okay? I don't have to rewrite my application to account for the fact that he got a new hard drive, or instead of a physical hard drive, he wants to write it to a network location. I don't have to do anything. And that's because the system is designed so that I can just remove these parts and everything continues to work. Hardware abstraction means the system will continue to work even though if I start swapping parts out. Okay. And it's done through, you probably heard this term API, Application Programming Interface. And as long as you adhere to the API, then your program will continue to run. Okay. The next thing to talk about is tasks, processing tasks. Memory management, that's pretty straightforward. Whenever the operating system, you launch a new application, the application says to the operating system, hey, Mr. Operating System, I would like some memory. And the operating system is going to say, go away, kid, I don't want to hear it. Or it'll say, hang on a second, let me carve you up a chunk. Okay, here's your chunk of memory that you can use. So one of its major tasks is managing memory. And so when my application dies, crashes, or I close it, then the operating system says, he's no longer using that anymore. Let me grab that chunk that I gave him and put it back in the pool of available memory for other people to use. So it's a good feature. Tasks. These terms are actually kind of sort of important, and again, it's from the salesman point of view. So multi-user basically means allows, two or more people to run programs at the same time on the same computer. Okay. You could have a server, and it could be that you've got 100 people running on there. That's okay. Multiprocessing means running a program on more than one CPU. Okay. Multitasking allows more than one program to run at the same time. So most of the time, most people these three right here, the multiprocessing, multitasking, multithreading, they get abused pretty badly. Multi-threading means a single application, one application gets broken into several smaller chunks, and each of these chunks run on different CPUs. So, for example, I have a game, and there's a splash screen that comes up while the game is loading. Well, if it wasn't for multi-threading, while that splash screen is there, nothing's going on. And then when the splash screen goes away, then it continues to load my program. Well, that's dumb. What I want to do is to work concurrently. As the splash screen is showing up, I want it to be loading my game. So by the time the splash screen goes away, the game is ready to start. So that's what multi-threading, a single application broken up into smaller chunks. And real-time, most of you guys will never run across a real-time task, but there are scenarios where they have operating systems that are designed specifically for like data acquisition, where instead of the operating system saying, "Here, kid, you can have some memory," it's kind of like reverse. The application says, "Look here, operating system, I need this and I need it now, dang it." And so it's kind of reverses the role of who's in charge of allocating resources. Okay, so that's what that is all about. Alrighty. Continuing, network capability, I mentioned to you guys that that's pretty straightforward. System resources and security, yes, of course. That, you know, if I'm Bob, I need to be able to see Bob's stuff, but I can't see anyone else's. You know, so passwords and access control, those kinds of things. I guess you could throw encryption in here in this category. File management, pretty straightforward. Just finding out, you know, where the heck did I put that? Okay. On page 172, they talk about some examples of some operating systems that operate in those 3 spheres of influence. That's a cool term. So in the personal space, you know, Microsoft Windows, Mac OS, Linux, Android, Chrome OS, those kind of guys. In the work group, it's typically Windows Server, Mac, Linux, you know, big boys like the Unix and IBM. And in the enterprise, yes, you can have Microsoft Server. Yes, you can have Linux and the big boys. It's kind of interesting to note that Microsoft has a product in each one of the spheres. You know, the Windows and the server, all in the same thing. Okay. In the Google world, this is a bit weird. In the Google world, they have, you know, like Android and Chrome OS, all sorts of weird things that are specifically designed just for one person. They're typically small, lightweight, and they don't necessarily need that much protection because there's only going to be one person at a time that's operating it. Microsoft, everyone knows about Microsoft. I'm going to skip a bunch of that stuff. You know, Apple, yeah, Apple Mac, been around a while. Yep. Linux is different. Linux is what's called free and open source, FOSS, free and open source software, FOSS. And it typically doesn't cost you anything. You can just download what's called a distribution. Now, here's the weird part. When Linus Torvalds wrote this, he wrote just the operating system piece. Okay, you following me now? What an operating system is? Operating system is a piece you don't ever see. That's what he wrote. He didn't write, you know, the GUI part and all the notepad equivalent and the music reader and, you know, he didn't write any of that. He just wrote just the operating system. So what good would it be if you were to download just the operating system? Well, you go, well, okay, it boots, but I can't do anything. So bundling together into what's called a distribution, then you get the entire package, and you get, you know, a file manager, and you get a, you know, a music program, and you get a browser for the internet, because none of those things, you know, file browsers and music reader listeners and browsers for the internet, those are not operating systems. Those are user applications. Okay, I think I drilled that into your poor little head too much. Let's continue. All right, Google is a little different because they have things in different camps. They have 2 different things going on simultaneously. Okay, work group, page 175. So work group server is typically those things for like a small network environment. So let's say, for example, I wanted to send an email, and I'm not talking about internet email across the internet. I'm talking about just inside my corporate world. I want to be able to send an email to the person in the next office over. Or I want to look at their calendar and see, you know, I'm trying to set up a meeting. And so everyone in the office maintains their calendars on this LAN. And then this network operating system will allow me to go in and find out that, hey, looks like, you know, Thursday at 2 o'clock is a good time to have a meeting because everyone's free. Okay, so Windows Server. Then there's some others. Yes, the Windows Server costs some money. The Linux ones typically do not. And there's some other things. the big Unix guys. Unix has been around for a long time, a lot longer than Windows, and it was originally designed, by AT&T, and there's been licensed to lots of different other companies, and it's big, robust kind of software. It costs money. Now the Linux part typically is about equivalent. I didn't say exactly equivalent, but it's pretty doggone about equivalent. The thing you get with a branded Unix like the HP UX and maybe the IBM flavors is that you're pretty much guaranteed that everything's going to work together because one set of developers put the entire thing together. With Linux, well, somebody wrote the browser and somebody else wrote this section. And so perhaps like the user interface will be different. Like the menu for this one won't have any resemblance to the menu for this guy over here. The applications. And so it's just kind of a hodgepodge of things thrown together. And if you're very tolerant of having just, chaos, then Linux is an excellent idea. If you're not tolerant of chaos, then move on. Mac OS server, I don't see too many people running this. It's a good server. And then the big boys, again, this is an HP version of Unix. Okay. So, in the enterprise world, it's kind of sort of the same thing. The big mainframe computers, and they're primarily made up with things like ZOS and then IBM UX again. Those guys. Yes, Linux is out there, and one of the reasons why Linux is out there in the enterprise is that, let's say, for example, I've got a special piece of hardware for which there's only like 5 of these things in the entire world. Well, how much energy am I going to spend putting together an operating system for 5 computers? I might as well just go ahead and use Linux because I can go in there and it's free and open source. I can go in there and do my own stuff and kind of tweak it a little bit and we're done. So I'm seeing an awful lot more of the Linux in that world. Okay. In the mobile space, you guys know what we're talking about. We're talking about, phones and tablets and those kind of stuff. Now, this is kind of an old description here. Talks about it in second quarter 2013, but it's actually still pretty relevant. Let me go ahead and just hit this little button here. So, comparing phone operating system. Now, I will tell you, this is not the case if you look just at like North America or the U.S., okay? Because right in the U.S., iPhone is king by a huge margin. But worldwide, Android actually has more phones out there than Apple. Isn't that pretty weird? And Microsoft Windows, it's struggling. I think they're up to like 4 or 5% now. Whoopee! And BlackBerry, they're hanging in there, but not by much. So essentially, the 2 major players in the world are Google Android and Apple OS. In the U.S., well, then it's pretty much game over with that regard. So looking at tablet, it's about the same. Android tablets and iOS tablets and Windows tablets are hanging in there. Although this was done before, like the latest and greatest versions of the Microsoft Surface. So I think they're probably up into the tens, maybe, if you would look at more current stuff. Okay. The next thing to talk about is embedded computers. Now, computers are everywhere, okay? So, my handheld GPS unit, my small camera that I have, my thermostat, my cruise control, everything that you can think of has a small computer in it. It's an embedded computer. And yes, embedded computers have to have operating systems. Yes, they do. Okay, this is probably a good place to stop for the 15-minute mark. We'll pick this thing up again in just a few.